In this video we're going to calculate the normal to a curve, and we're going to start off using the same curve that we just used to find the tangent, but this time we're finding the normal. And first of all, what the normal means is this line here. So it's the line which is perpendicular to the tangent, so this is called the normal, and the blue one that we had here was the tangent. So a curve is the red line, and the tangent is the one that just passes through this point here and goes at the same gradient as the curve has at that point. The normal has the perpendicular gradient. So because it's at right angles here, that means that it's perpendicular to the tangent. And it still passes through the same point, so we're still using this point, which was 4, -1. So that's the point we're using. And so the question says find the equation of the normal. So the difference here is it says normal instead of tangent to the curve at the point 4 and -1. And this is the normal that we're trying to find. And we know that the gradient of the tangent, if you remember from the last question, the gradient of the tangent was 2. And that from here we can calculate what the gradient of our normal has to be, because we know that the gradient of the normal is always -1 over the gradient of the tangent. And this just comes from the rule with perpendicular lines. So if you have a perpendicular line, the gradient of that is -1 over the gradient of the other one. So it's the same as -1 over 2. So this is going to be our gradient, and we can start straight away putting this into our straight line equation, because we know the gradient and we know the x value and the y value at one point. So we know one point and we know the gradient, so we can use that to calculate c. So let's put all our values in. So y is -1 and the gradient is -1 over 2, x is 4 and c is just c, and that's what we're going to calculate. So we've got -1 equals -1/2 times 4 is just -2 plus c, and if we add 2 to both sides we see that c equals 1, and that makes sense on the picture here because we see that it crosses at 1, so we already have the answer because we know everything in our straight line graph. So we're going to write down y equals -1/2 x plus 1, and that's the equation of our normal at this point. And let's just quickly check it in the calculator. So I still have the tangent written there, and let's just add on the normal. So we've got -0.5 times x plus 1. And okay, it doesn't quite look normal on, it doesn't quite look perpendicular on the calculator because of the scale. So it's because we have we're doing from -10 to +10 both on the x and the y axis. That means that the size of 1 across here along the x is bigger than the size of 1 along y, because the screen is not perfectly square. And I'm not quite sure how to change that. So, but you can see that it's the line that looks almost perpendicular on the screen. And we can check that it does cross the curve at this point. So if we do calc intersection, and the first curve is the quadratic, second one is not going to be that, and it's not going to be that, it's going to be this one. And our guess is that they cross around here. They obviously do also cross over here, so let's make sure our guess is close by. Yeah, so the intersection is when x equals 4 and y equals -1, which is what we wanted. Okay, let's look at another question. So this is one that we haven't sketched, and we don't know the tangent to it, so we're going to have to calculate the normal from scratch. So this is the curve, and we need the normal at this point. So let's start off by writing down the curve as a negative index. So this is the same as 1/2 x to the power of -2, and we differentiate that to find the gradient. So -2 times 1/2 Well, let's write it down. So minus 2 times a half x. And the power goes down by 1, so it becomes negative 3. And we can simplify this a bit because minus 2 times a half is negative 1. So it's the same as negative x to the power minus 3, which is negative 1 over x cubed. So this is a gradient at every point. And we can calculate the gradient when x equals 1, because the x value here is 1 at the point where we want the normal. So when x is 1, dy by dx equals negative 1 over 1 cubed, which is just negative 1. But we don't want the tangent, because using this gradient will give us the tangent. We want the normal. So this is the gradient of the tangent. So the gradient of normal is going to be minus 1 over what this gradient was. So minus 1 over minus 1, which is just 1. So our gradient is 1. And we can put that into y equals mx plus c, because now we know everything except c. So we put the y value in, which is a half. Put the m value in, which is 1. And the x value is also 1 plus c. So 1 plus c equals a half. That means that c is negative a half. So the final formula is going to be, let's write it here, so y equals x minus a half. So this should give us the normal at that point. And let's see what this looks like in the calculator. So I'm going to go and let's delete the other ones that we had. So the formula we have now is 1 over 2x squared. Make sure you put brackets around this. And let's see what the graph looks like. Okay, so I can't see it very well, so let's zoom in a bit. So as we saw, we only got positive values. So y we can have between just minus 1 and 10. So we can see a bit more of the values. And x, we know that we're interested in fairly small values of x. So let's do between minus 2 and 2. And now we can probably see it a bit better. Okay, so let's also plot the equation of the normal that we calculated. So x minus 0.5. And that's what it looks like. So again, because of the scale, it's not going to look perpendicular. But one thing we can check is that they meet at that point. So we can calculate the intersection between, let's see, okay, so there's this curve, yeah, and the other curve, which is that one. And then we're guessing that they cross around there. And it says that x equals 1 and y equals 0.5. Which, if we compare that to the original point, that's the same. So that's the coordinate where we wanted them to cross.